Hello. Let's continue talking about the behavior of particles. There are many predictions about how electrons behave and how they move and so on. But scientists, in different ways and forms, have theorized that the electrons move in circular orbits around a fixed radius or a fixed nucleus per se. And these moving particles of electrons all behave in certain ways, having a wavelength, having certain frequency, and having therefore some energy. So therefore, they predicted that all moving particles have some characteristics of waves. Let's look at an equation and see how it applies. So I have lambda, which is my wavelength. Lambda equals h, which is constant for Planck, divided by mass times velocity. That would give me wavelength. What if I want to solve for, let's say, mass? I will bring m up and this down. Now I have mass equals Planck's constant divided by lambda, which is wavelength times velocity. How about if I want to solve for velocity? Okay, let's do this. Bring the mass down again, bring the velocity up, and this will give you velocity. Let's do some examples. Example 1. Very important, identify what you're looking for, see what you want to find, and solve for that. If a particular substance has a mass of 478 kilograms and a velocity of 31 ms, that's meters per second, find the wavelength. Okay, looking for a wavelength. If I recall the equation says, let's bring this down a little bit here, wavelength equals Planck's constant divided by mass times velocity. That's wavelength. Okay, so let's plug those values in. And I have Planck's constant, which is 6.626 times 10 to the negative 34 divided by the mass given to me, which is in this case 478 kilograms, times the velocity given to me, which is 31 meters per second. When I plug that into the calculator, my results comes out to be 4.47 times 10 to the negative 38 meters. And that would be the wavelength. If by any chance this wavelength is out of the spectrum, understand that this wavelength, these numbers, I just made them up just to throw in some samples into the equation. Let's do another one. Example number 2. Sample 2 says the wavelength of a particle is 2.78 times 10 to the negative 4 meters, and the mass is 3.07 times 10 to the negative 20 kilograms. Find the velocity. Okay. My original equation says lambda or wavelength equals h divided by m times v. I'm looking for velocity. Therefore, I will change the equation and have velocity on top equals, which is the same thing, h on top divided in this case by m mass and lambda wavelength. Okay, now I'm ready to plug in my numbers. Let's bring this down a little bit. I need more space probably. And I plug in for h 6.626 times 10 to the negative 34 over my mass, which is, they give me 3.07 times 10 to the negative 20th. That's kilograms. Put that in brackets just to play it safe. And that'll be times the wavelength given to me, and that is 2.78 times 10 to the negative 24. That'll be meters. Okay. When I plug all that into the calculator, my response comes out to be 7.76 times 10 to the ninth. And since I'm looking for velocity, it will be to the ninth, in this case, meters per second. Moving on, let's do one more sample. Sample 3 says, in a certain atom, the mass is 1.98 times 10 to the 19th, negative 19th kilograms. And the wavelength is 5.31 times 10 to the negative 28. Okay, let's move on and plug these values in. I'm looking for velocity. Good. So when I move my equation around, I end up with velocity equals h over m times lambda, or wavelength. Plug in your values again. 6.626 times 10 to the negative 34 over, open brackets to play it safe, 5.31 times 10 to the negative 28 meters, very small, close brackets, times, open again, 1.98 times 10 to the negative 19, of course in this case is kilograms, close brackets, and equal sign. When you plug all these values into the calculator, you end up with 6.3 times 10 to the 12. That'll be, of course, meters per second, because I'm looking for velocity. Again, if these numbers do not match the spectrum, okay, our purpose here is to work out the equation. I hope this helps you out.